Hello all and welcome to your lesson for today on walking through how to do a chi-square test on Minitab. Oh good, I'm failing to print things. Yay. Uh, what I have open right here is the chi-square test document lesson for case study 7, and I'm now going to open the Minitab portion. Okay. Here she blows. Alrighty, and I'm just going to dual screen this. Alrighty. So let's make this nice. Good enough. Alright, so it's weird my data's on top. Why am I even bothering? Why do I care what it looks like? That feels more natural. Okay, so what we're interested in is we're wondering if, hey, have real estate agents shown prospective buyers homes in a neighborhood already dominated by the family's race? So we're looking, is the relationship between which section of town these individuals are in and race. Yep, so there's two variables here, race and section of town where the place has been purchased. So clearly we're looking for an association between these two variables. Are the two related? So that's going to be my null hypothesis. There is an association between race and let's go with complex section. So like what section of the apartment complex that is going on that was being sold. I'm going to increase the size of this so it's easier for you to read. So the opposite, the alternative hypothesis for us is going to be is there is not an association between race and complex. So the first thing we're going to do is we're going to come up with our observed values, and we're going to do that by a tally count. Everything we need to perform the chi-square test is found in the table section. So you've done a tally individual count before. Back when you were in Stat 1, but in case you forgot how, here's how we do that. So I have non-summarized data down here, and what we're going to do is we're going to take that, we're going to tally it into a table, a cross-tabulation like we see down below. So I've got raw data, my rows are the race counts, and my columns are going to be the section counts. So again, I'm choosing oh no, wait, I've got this backwards, because if you look on this, I've got race as my my columns, not my rows, so I need to fix that. I've got these exactly backwards. Yay! So again, my columns is my race, and then I did it wrong again. How did I do that? Yeah. And then my rows, which are going across, are going to be my section counts. If you have a hard time remembering that, I always think of like Roman columns. They're very vertical, up and down, so that's how I know that's the columns. And then rows are like rows of seats, so they go across. I don't know, just a little trick to help you remember what's going on there. Alrighty, and all I really want is counts, so that's what I've got displayed. Now there is an option in cross tabulation if you want to pull up the chi-square test, but I'm going to not check this because I'm not going to do a chi for now. If you do check this in one of the other videos that I've got in your list of videos for today, it does do this, goes through it this way, and it, it's different. So there you go. I'm going to hit OK. The other thing I'm going to do is, since in part 3 or step 3, we're going to need the expected counts, I'm going to go ahead and click that value now so that I can get the expected counts right away. And that'll, save me a step. You don't have to do that here. I'm going to hit OK. And there's our cross tabulation. So section A, the top number is our observed, the bottom number is our expected. So I'm just going to go ahead and copy that data over here. So 8 for my expected for black, and in section A, white, and in section 8 in A is 87, and then 34 and 83. I don't need the totals for this. And then in my expected, so that's going to be the numbers below. So 18.82, 76.18. Looks like there's a difference already, but there's only one way to tell if it's significant or not, and that's to perform an actual test to see if it's a statistically significant difference. Okay, so now we're going to go ahead and find the chi-square test statistic. Now, there are lots of ways to do this. We can go through what we just did, where we went into stat tables and then cross tabulation and chi-squared, and just make sure we select that button there for chi-square test. I'm going to Hit OK twice. That's one way, and it gives you the Pearson chi-squared, along with the degrees of freedom and the p-value. The other way to do this is if you go through and choose stat tables, there's two chi-squareds in here, the test for association and the test for goodness of fit. This is only for one variable. We're not doing that. We're doing the test for association. If you do the test for association way of doing this, you can just go ahead and fill out your raw data as is. So, you know, rows and then columns. Oh, I got this backwards again. I want my rows to be sections and my columns to be race. And if you hit stats here, you can choose some other values. I don't really need marginals. I'll choose to have the counts and the expecteds. And if you want, you can take a look at the residuals to see if they fit your other requirements. We'll hit OK twice. And notice it comes out exactly the same. So it's just two different ways to do this. Alrighty. So how many degrees of freedom? We can read that right off of our output. There's only one, because as you look at this, this is a 2 by 2, so if you subtract 1 from 2, you get 1. You subtract 1 from 2, you get 1. So 1 times 1 gives you a 1. Woohoo! Degrees of freedom is 1. Down with the DF, yo. Find the p-value. Oh, look, it's very tiny. Now, there's another way you can do p-value too. So if you want something a little bit more accurate, we can go up to graph, probability distribution plot. I want to do view probability like we usually do, and instead of normal, I am going to choose the chi-squared. So since this is alphabetical, oops, sorry. We need to rule on up to the chi-squared. My degrees of freedom is 1, and I want to shade the probability. Oh, I have an x value, and that's my test statistic, the chi-squared test statistic, the 14.058. And I want to do right-tailed because the chi-square test is always a right tail. We'll hit OK, and it will produce this lovely, lovely graph for us. So notice this is a very, very sharp chi-square because I have very small degrees of freedom. Not normal looking at all. Very much tailor. But notice it also gives us a more accurate p-value, something better than 3 decimal places. So if you want to be more accurate and give some, more detail, you can use this p-value, which is 0.0001773. So just in case you wanted to be specifying like just how tiny this is, there you go. Alrighty. Now, for a tiny, tiny p-value, remember that indicates that I have something that just shouldn't be happening if my null hypothesis is true. So this sorts of points at the alternative, and so we are going to definitely reject some of this. So it appears that there is not an association between these two. It appears that the choices made were caused by random chance, or perhaps another lurking variable. But as of right now, like where people ended up purchasing, appears to not be associated with race. But there might be something else going on here. Alrighty, and that's all I have for you today. Interesting, I hope. I'm gonna pull up my menu. Come on, there she is. Bye.